There are 5 ways to prove that triangles are congruent, where you don't have to know that all 3 angles and all 3 sides are congruent, but just there are going to be 5 different ways where you need fewer than all 6 pieces. And the 3 most important ones that are the subject of this video are called SSS, SAS, and ASA. And I'm going to explain what these mean in this video. What SSS means is that if you have 2 triangles and they may look congruent, one might be a sort of a backwards version of the other, so it's hard to tell. But if you know that the short sides are equal to each other and the medium sides are equal to each other and the long sides are equal to each other, then we can say that these triangles are congruent by what's called the SSS postulate. And that is, that's what SSS means. Now, in a proof, this might come up something like this. Here's 2 triangles that are kind of back to back like this. And maybe we're given that these 2 sides are equal. And maybe we're given that this is a midpoint. So we're trying to prove that this red triangle here, make it a little brighter, is congruent to this blue triangle. And we're given that one of the sides of the red triangle is congruent to one of the sides of the blue triangle. But if this is given as a midpoint, then we also know that this side equals this side. And since these triangles both have MC, they share that side. I go like that. So these 2 triangles, triangle ACM is congruent to triangle BCM. And the reason would be side, side, side postulate. That's what side, side, side means. The next postulate for this video is called the side angle side postulate. And the way the side angle side postulate works is if I have 2 triangles, I'll even make this one maybe an upside down version of it. So here's 2 triangles that may or may not be congruent. But if I tell you that this side is the same length as this side, and that this side is the same length as this side, that's 2 sides. Now, if I give you the 3rd side, then we could use SSS. But there's another thing you could have at this point, which is an angle, but not just any of the 3 angles. Specifically, if this angle between the 2 sides is congruent to that angle, then we can say the triangles are congruent. Triangles congruent by what's called SAS. It's very important that the angle, if you imagine here's one of the congruent sides and here's another one, those 2 angles form, those 2 line segments form a V, and that V has to be the angle. So that's how SAS works. Now, just to show you something that's not SAS, because this can get kind of confusing. So here's a triangle and here's another one. Now in this triangle, I know these sides are equal and that these are equal. And I know that this angle is equal to that angle. So that may seem like it's a lot of information, but it's actually not enough. This is not SAS. And the reason it's not SAS is because this angle and this one are not in between. It's called the included angle when it's between the 2 sides. So this is not an SAS situation. The 3rd triangle congruence postulate is called ASA. And the way it works is if I have 2 triangles that they might look congruent, but maybe they are, maybe they aren't. And we're told that this angle is congruent to that angle, and this one's congruent to this. And now I get one more piece. Now, if that piece is, so these angles, the included side means in this one here, it's on the left, it's this. That's the included side. It kind of attaches, it's a line segment connecting the two vertices. That's a good way to think about it. And in the other picture, that's the included side. So if I'm told those are congruent, then we can say the triangles are congruent by ASA. Now, if I had the same picture and I knew these two angles again, but I had this side and that side, that would not be, it's really not enough information to make any conclusion. Maybe these are congruent, but they don't have to be. But when it's the included side, then AS angle side angle is enough information. If it's not the included side, because this side's here, it's not the side that's connecting the two vertices of the congruent angles, it's not enough information. It's not ASA. So there are more properties coming up in future videos, but for right now, those are the three properties. Now let's see how these come up in problems. These are some fun kind of short questions. So here we have two triangles that may or may not be congruent. We have side, side. That's not enough, except we also have this shared side in the middle. So this one is side, side, side. For this one over here, we have this side is congruent to that side, and this side is congruent to that side. I'll just go like that. So we have two sides. Now, the question is, do we have what's called the so-called included angle? And the answer is yes, this right angle is congruent to that right angle. So this is an SAS situation. This third one here, I have two angles, but I also have, in these two sort of back-to-back triangles, I have this shared side in the middle. So I have two angles in one triangle, congruent to two angles in the other, plus the shared side. This is ASA. This one over here is three angles, so that's not, it's none of these. It's not of these four choices, it's not any of them, of these three choices. This one, I have an angle. I should use some color here. Let's see, what's a good... So I have this angle is congruent to that angle. I also have this angle is congruent to this angle. And I have a side, just is it the right one? And the answer is yes. That's the included side. It's between the two angles, so is that. So this one is ASA. And this one over here has two angles, but the side is the wrong side, so it's none. So those are some quick questions like that. Now here's a two-column proof based on these. So we want to prove that this red triangle is congruent to this green triangle. And right now it doesn't seem like we have any information, but then they tell us AD is congruent to CD. So that's one side. They also tell us that B is the midpoint of AC, so that gives us another pair of sides. And this BD side is part of both. So this is an SSS situation. You can see in the proof, AD is congruent to CD given. They tell us it's the midpoint, but we need to turn that into a congruent statement. So AB is congruent to CB. You could just say definition of midpoint. And I like to put a little S here to say I've done a side, put an S here to say I have another side. BD is congruent to BD. Those are my three sides. Here I say side, 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 and I say which three steps, which were 1, 3, and 4.